Alright, let's take a look at this problem. What we have is a number line, and they tell you that point B is actually the midpoint. So, you know that A, B, and B, C are equal to each other. And we have to solve for n. We want to find, I'll put n equals question mark. Okay, that's what we're trying to solve for, and that would be right here. Trying to find out what that value is. Well, if B is the midpoint, I'll put a little tick mark here and here. Hopefully that doesn't mess up with these little marks anyway, but these two segments are equal to each other, so this is the midpoint. Well, we have a midpoint formula. If you remember the midpoint formula, I guess, I don't know if you really consider it the formula, but what you can do is to find the midpoint, you take the two numbers on the outside, add them up, divide them by 2, and that equals this middle number right here. So that means that n times 2 to the k is equal to, what am I going to do? I'm going to add them up and divide by 2, or take half of the sum of the two endpoints. So it's going to be 2 to the k plus 2 to the k plus 4. You could put this over 2 if you wanted to. Either way, it doesn't make any difference, because what I'm going to do here, actually, you know what I'm going to do? I was looking at my notes because I did this one already. Let's go ahead and divide this by 2, just like that. Alright, the reason I'm going to do that is because I want n by itself. I was going to take that 1/2, put it over here, and put a 2 over here, but you know what? I'm going to get rid of it anyway because I want to get n by itself. I put it back here, so it's a little redundant. So I'm just going to put this over 2. So this is basically midpoint. Alright, so again, how do you find the midpoint? You add the two endpoints, divide by 2, and that gives you this midpoint right here. So what we want to try to do is get rid of this n. So I have to get, I misspoke. Not getting rid of the n, but I want to solve for n. I want to keep n right there. I want to get rid of, this is what I was going to say, I want to get rid of this 2 to the k. So I divide by 2 to the k. Now, if I divide by 2 to the k on the other side, then what happens is that goes down here on the bottom, just like this. Alright, so I divided by 2 to the k, I've got 2 to the k down here on the bottom. Now, it might seem like we want to put everything on the top, and I guess you could, and eventually we will, but I'll just show you how I did it. Again, I'm not sure if this is the very best way to do it. This is just what came to my mind, and we'll see if it works. This is 2 to the first. Now look, these have the same base. Now notice, this has a k plus 4 right here, and this has a k. Yeah, I don't know really how to tell you how I thought of this. I don't know. I just thought this would work nice because I can't add these together. They're not like terms. I can't really add them together. Alright, so what I decided to do was split it up, actually. You'll see here in a second. Let me just do what I was going to do. Just show you and quit talking. So it's 2 to the k. I'm going to keep this as the exact same thing up here. I'm not going to change this just yet. But what I'm going to do is I'm going to mess with the bottom a little bit. See how this has two 2's? I've got a 2 times the first times 2 to the k. What I want to do is kind of make it look a little bit more like this one. So what I can do is it has the same base. Now it kind of, what do you do when you multiply numbers with the same base? Well, if I multiply numbers with the same base, you add the exponents. For instance, you've probably done this before, like x to the 3rd times x to the, I don't know, the 5th. You're probably very familiar with this. What do? You keep the same base and you add the exponents, 3 plus 5. It's really what I'm doing right here. I'm keeping the same base, which is 2, and then I'm adding the exponents, 1 plus k, or I'm just going to make it look a little nicer and put k plus 1. Alright, let's get rid of this right here. Alright, you say, well, how does that help me? Well, let's see. What I can do here is this. I was trying to figure out how many steps to show you. I'll just do this. Watch what I'm going to do. I'm going to take this. I don't like it in the denominator, and I'm going to put this up to the top. But you got to remember, it's all this stuff. If I'm going to take this and put it up to the top, hopefully you remember that step. For instance, if I had, I don't know, x to the 5th, and I had x to the -2nd, or actually, let's not even put to the -2nd. Let's put x to the 2nd. What if I had this? There's a couple ways you could do this, but you could also do it like this. You could take this, you could put it up to the top. The base stays the same, but what do? You change the sign of the exponent. It's x to the -2nd. So now you can actually just do a multiplication, and that's going to be x to the 3rd. Alright, so that's really what I'm basing this on, what I'm doing right here. Hopefully that makes sense. I'm going to take this, put it up to the top, so I'm going to get 2 to the negative k plus 1. Alright, so if I take this, throw it to the top, it becomes Still my base is 2, but my exponent becomes negative now. Negative, and then parentheses k plus 1. Alright, but what's that being multiplied by? It's being multiplied by all this stuff right here. So really, I haven't changed this at all yet. Now what I'm going to do is we're going to do some multiplication here. Let me think the best way to do this. Let's do this. Let's not have this negative outside of this. Let's just distribute the negative through. So that would be 2 to the negative k minus 1 times 2 to the k plus 2 to the k plus 4. Again, you might be able to skip some steps here. It's all how comfortable you are with this stuff. So now what I'm going to do is I'm going to multiply these together. So if I multiply them together, again, what do? I keep the base the same and I add the exponents. So it's negative k minus 1 plus k. Alright, kept the base the same, just added the exponents. Negative k minus 1 plus, this is 2 to the k, sorry about that. That shouldn't be 2k. 2 to the k. Wow, it makes a big difference. Okay, so then there we go. Plus, again, we're just distributing this times this. So it's going to be, you keep the base the same, so 2 is my base, and then I add the exponents. So let's just keep negative k minus 1 plus this exponent plus k plus 4. Again, you could have done some of this in your head, but I just want to show you all the steps just in case. So what do we have here? Let's simplify this. Negative k plus k is 0. So this is really just 2 to the negative first. Okay, that worked out pretty nice. What about here? Negative k plus k, that's a 0. Negative 1 plus 4, that's a 3. Ah, now we're on to something. Look at this. 2 to the negative first. Well, 2 to the negative first is the same as 1/2. Remember, you could take the exponent, flip it to the bottom. Watch, take that whole thing, flip it to the bottom. Not just the exponent, but flip the whole thing to the bottom. It'd be 2 to the first, so it'd be 1 over 2 to the first, which is 1 over 2. Plus 8, right? And then there we go. This is, what, 16 over 2 plus 1 over 2 is 17 over 2, and that's how they write their answer. Just like that, 17 over 2, and that is choice E. Alright, check this one out. This is crazy. Took me a while to draw that thing, but I think it looks pretty good. Say if I say so myself. Alright, what I decided to do, instead of calling these by the names of the circles, what I did was this. I'll just call this little circle inside of here circle 1, call this circle 2, call this circle 3, I guess you can see that, and then we'll call this one circle 4. So the inside is circle 1 and the very outside, the largest circle, is circle 4. And we are trying to find the area of the shaded region. So this pink purplish color right here, that's what we're trying to find, is the area of the shaded region. And they also tell you another thing. They tell you that each of these lengths right here, AB right here, which is 1, I'll tell you what, let's do this in another color. So the length of this is 1, the length of BC is 1, CD is also 1. So you need to know that. Remember, these aren't lengths or anything. This is just how I label the circles, 1, 2, 3, and 4. I just thought it'd be easier to see it that way. Alright, I'll tell you what, let me do this. Let me scooch a circle over so give me some room to write and I can still see the circle. Alright, here we go. So what do we have to do? We got to find the area of the shaded region. So what I'm going to do is I'm going to look at circle 3. Circle 3 would be that whole entire thing right there. Okay? And if I took circle 2, because 1 is included in 2, alright, so I don't even have to think about 1 right now. If I could just take 2 away from 3, then I should be fine. I should be able to find the area of just the shaded region, right? Because circle 2 is covering up a lot of circle 3. I don't know if it's most, probably most of circle 3, quite a bit of circle 3. So I'm going to try to get rid of circle 2, and what I'm going to be left with is circle 3, and I'm sorry, what I'm going to be left with is the shaded region of circle 3. So take circle 3 and take circle 2 away from it, and there we go. So the thing is, I have to figure out what the radius is, because remember what area is. Area, let me write this down. So area of a circle is pi r squared. So the radius is the important thing to find. So let's take a look. It also says that D is the center of the largest circle. So see circle 4, which is the whole big circle. D is the center of that circle. So what I can do is I can find actually the radius of the whole big circle. So if that's 1, 1, 1, the radius is 3. So that means the diameter of this little circle is 3. Yes. So the diameter is 3. So the radius of this little circle is 1.5. And I'll just put 1.5 right there. I'll put 1.5 right there. Okay? So that's the radius of the little circle. So what's the radius? Remember, what I want to try to do is take, we'll call this circle, that's the symbol for circle. We'll say circle 3 minus circle 2. If I find the area, I should say area of circle 3 minus the area of circle 2. Okay, so let's find the area of, let's see circle 3. Let's find it. So all I have to find is the radius to find the area of circle 3. And so let's see what that would be. Circle 3 goes from here, and first of all, let's find the diameter first, because I'm not sure where the center is. So we go 1, 2, this is 3 right here. That whole thing is 3, so the diameter from here to here is 5. So the radius of circle 3 is 5 over 2, or half of 5. You could put 2.5 if you wanted to, but I'm going to put 5 over 2. It just makes it a little easier, I think. So the area of circle 3 is going to be pi times the radius, which is 5 over 2 squared. Do you see where I got the radius? So from here, from B all the way to E is the diameter of circle 3. And if I count, that's 1, 2, and then that whole thing is 3 right there, so that's 5 altogether. So the diameter is 5. We want to find the radius, so the radius is half of the diameter, so 5 over 2, and I'm going to square it. So let's see what I get for that. We'll keep it in terms of pi, because all our answers, all our multiple choice answers are written in terms of pi, so we're not going to use a calculator on this. So I'm going to go 25 over 4 pi. So 25 over 4 pi. That's the area of circle 3. Now that would be the whole entire pink circle if it wasn't covered up by circle 2. But it is covered up by circle 2, and I want to find out what's just the pink part of this. So I got to find out circle 2, the area of circle 2. So let's do the same thing. Let's find the radius of that. First of all, I'm going to find the diameter. Well, from here to here is 3, plus that 1 is 4, so that's easy. So the radius of circle 2, just circle 2, is going to be 2. So minus, let's do this, put it up here. So it's going to be pi times 2 squared. So the radius is 2, I have to square it, it's 4, so it's minus 4 pi. Well, the math is pretty easy now. It's just 25 over 4 pi minus, let's write this over 4, since we have a common denominator, that would be 16. See, 16 over 4 is the same as 4 pi. 25 minus 16 is 9, so it's 9/4 pi, or 9 pi over 4, which is the same exact thing, just written just a little bit different. And that is one of our answers, and that is letter D.